Hey guys, so right back at it, what we're going to do is we're going to look at what makes a minimum and a maximum. Now, starting off and looking at this from a very base level, it's funny, even on grid paper I can't draw straight lines. If I have some function, and we're just going to make up some weird function that will start all the way off from here, and we'll pretend it goes towards an asymptote, then it's going to go up, down, then it's really going to go up, then it's really going to go down, and then it's just going to sort of drift off into that way. And just for argument's sake, we're going to assume that there's a horizontal asymptote there, and we're going to assume that there's a horizontal asymptote going on right there. Now, it can be very easily seen that we have a couple of tops and a couple of bottoms on the graph. So looking at this, you could see that we have, well, we have a maximum right there. We have a minimum right there. But then we also have these two bad boys right here, where it goes down and it looks like it could be a minimum, but not quite because there's something lower on the other side. And again right here where it looks like it could be a maximum, but again not quite because there's something on the other side. So what we're going to do is we're going to name these. First of all, looking at the ones that are at the very top and the very bottom, we're going to call this an absolute, or rather a global maximum. And I'm going to put global into brackets right there. You can call it either one of those. So you can call it an absolute or you can call it a global. Here, the exact same thing. We call this an absolute or we call it a global minimum. Now here, it's not the lowest point on the graph. So we're looking at this one right here. That's not the lowest point on the graph, but it's with the lowest point within its little sort of section on the graph. So we're going to call this a local minimum or a relative minimum. So it's going to be a relative, or rather a local minimum. And here we're going to call this a relative, or rather a local maximum. So we have a relative or local minimum, relative local maximum, absolute global max, absolute global min. And it is good to know that when we're pairing these off, global goes with local, and then absolute goes with relative. So if you're looking at the proper way to group these when you're referring to them, absolute relative and local and global. Now, taking another sort of look at what's going on here, we're going to talk a bit about the derivative and how that affects the shape of the graph. So again, what I'm going to do is I'm going to try to draw a more straight line. I'm getting better. And we're going to draw a graph in that basically is just going to go up and then it's going to go down. Now, looking at this right here, we can see that as I'm going upwards, if I draw those tangent lines in, so if I have a point right there and I draw that tangent line, point right there, draw that tangent line, point right there, draw that tangent line, that everything on my left-hand side here of that maximum is positive or it's going up, or f prime at x would be positive in that case. If I look at my other side, as everything's going downwards, we see that the f prime x is negative. So on this side, my f prime at x would be less than 0. And on this side, my f prime at x would be greater than 0. So then that begs the question, what happens in the middle? And in the middle, well, if we draw that tangent line in right there, we see that it's going to be a horizontal line. And we know that the slope, that color did not come through well with that. And that did not erase it. And we know that the slope of a horizontal line is equal to 0. So that tells us that f prime at x is going to be equal to 0. So what does that mean about f prime at x? Well, it means that when f prime at x equals 0, we can either have, there's a possibility of a max or a min. Now, it could be a local or a global. We will talk more about that later. But the main thing to get out of this is when f prime at x equals 0, there's a possibility of a minimum or a maximum at that point in time. Now, you'll also notice that I use the word possibility right there. The word possibility is very, very important because we don't necessarily have one. If I wrong color. If I quickly sketch out my graph of y equals x cubed. At the point when x equals 0, if I draw that tangent line in right there, we'd still get a slope equal to 0 on that tangent line. I'll rewrite it in black just so it's a bit more clear. So the slope of the tangent line would still equal 0, and that means that f prime at x would equal 0 at that point. But you notice I don't get that minimum or the maximum there. So that's where the word possibility comes into play, and that's what makes it important. Thanks for listening, guys. I hope you enjoyed.